everybody! Welcome back to my YouTube channel. My name is Ria Lutfiah Muhdy from 11.1. Today, I would like to tell you or share my explanations about how I get this formula. So, keep on watching. To answer these questions, first step that you should do is draw the free body diagram. As you know, in this ballet, there is a rope and there is a beam. There is beam 1 and beam 2. In beam 1, we get weight force over here, and then in beam 2 we get weight force 2. Then as you can see, there is a rope in here, so in rope there will be a tension over here, tension 1, tension over here, tension 2, and this ball or this ballet have a tension 2, like this. Next step is you look at the beam 1. Just look at the beam 1 without looking at the beam 2. So, as we know, there is second Newton's law, which is sigma F is equals to m times accelerations, where in beam 1 there is force, which are weight, force, and tension. As we can see, there is the acceleration, so if the acceleration is go down, so the force that go down is positive. So it will be weight 1 minus tension 1 is equals to mass times accelerations. Then we can say that tension 1 is equals to weight 1 plus m1 times a. So we got the first equations. This one is for beam 1. Then we can look at the beam 2 over here. It is as same as the beam 1, so we can write sigma F times mass times acceleration. Why we use sigma F times equals to mass times acceleration? Because this ballet or this machine is moving, so we use this Newton's second law. Okay, going to the beam 2. The force that have in beam 2, without looking beam 1, so there is tension and weight force. As we know, the acceleration is going up. So if the acceleration is going up, the force that going up is positive. So the force is going up is in here is tension 1. So tension 1 minus weight 2 is tension 2 time equals to mass times acceleration. Then we can write that tension 1 is equals to weight 2 plus mass 2 times a. Then, and we got the second equations. Then we look at the pulley. This is the pulley. This is the pulley. So it is same as beam. If we look beam 1, so we doesn't look the pulley and the beam 2. Then if we look the beam 2, we doesn't look the beam. We don't look the beam 1 and the pulley. It is same for the pulley. We can write over here for pulley. For the pulley, because the pulley is going in rotational motions, so we can write it sigma tau is equals to inertia times angular velocity. As we know, sigma tau is equals to F times R. Inertia is equals to K times mr square, and then the angular velocity is times to A over R. In these equations, we can eliminate the R. So cross this one, and then cross this one, and then cross this one. For the force, we don't look the beam 1 and beam 2. Just look at over here. There is tension 2 that going down and tension 1 that going down too. So we can write is tension 1 minus tension 2 is equals to K times A and times M. We got these equations, so we can write that tension 1 minus tension 2 is equals to constanta times mass times acceleration. So we get the equation 3. The next step is we combine the equation 1, equation 2, and equation 3. So we combine equation 1, 2, and 3. So it will become weight 1 minus mass 1 times accelerations minus weight 2 plus mass 2 times accelerations equals to constanta times mass times accelerations. We put it, why I got these equations? Because we substitute the first equations and the second equations to the third equations. Because tension 1, we know that weight plus m times a, so we substitute in here, so become here, because become in here, and then we substitute the tension 2, this one, weight 2 plus m2 times acceleration, so will be like this. Then in here, because there is 2a, so we can take the a like this out of these symbols, and then so we can write is m1 plus m2 plus constanta times mass, like this, is equals to weight 1 minus weight 2, and then it become like this. A is equals to weight 1 minus weight 2, weight 1 minus weight 2 over this one, m1 m2 plus constanta times mass. So this one, the step how I get this formula, so the first step is this one, second step, third step, and fourth step. It's easy, right? And then we going to the second questions. Okay, next question 2. As I said before, I will continue to the second questions. So this is the second situations. There is a ball that over or above in the rough field. As we know, the first step is same like the question number 1. How I get this formula? So you should watch this until the end. So the first step is we draw the free body diagram. Same with the question 1. So as you know, there is weight force in here, and then the weight force is, and then there is the normal force in here, and then as we know there is a rough field, so in rough field we got the force 2, which is friction force. So what we will do now, so because we know that if the ball or the rock is moving, so it will be moving in linear motions and rotational motion. Why rotational motion? Because the ball is going down and then going up like a ball that when you play, and then why linear motion? Because the ball is going or moving in x coordinate. First, we can write it sigma f times m times acceleration. Why we use this formula? Why we use this Newton's second law? Because as we know in these situations, the ball is moving, not stay. So we use this Newton's second law, and then as we know, the sigma f in this situation, there are f as a force minus frictions. This one frictions times equals to, m times a. So we got equation 1, and then we look at, because it is rotational motions, so there will be a torque. So we write with this formula, sigma tau is equals to inertia times angular velocity. As you know, the sigma tau or sigma torque is equals to F times R, equals to inertia, as I said before, inertia is constanta times mr square, and then the angular velocity is RA over R. So we can eliminate the R, so cross this one, cross this one, cross this one, cross this one. Oh my god, it is so excited, yeah. And then force is equals to constanta times mass times acceleration. So we get the equation 2. The next step is we substitute these second equations to first equations, because we know that F is equals to constanta times mass and accelerations. So we can write it substitute equation 2 to 1. Okay. So, as you know, the first equation is F minus frictions equals to mass times A. As you know, the first is equals to constanta times M times A. So, we can write that constanta times A minus frictions equals to mass times accelerations. And then, we change the position, so it will be K MA minus MA is equals to minus F. Then as we know, there is 2A in here, so we put the A is in the outside of this symbol, so it means minus MA plus M minus F. There is minus in here, minus in there, so we can cross it. For getting this formula, we look at A is equals to F over K M plus M. So the M, we can pick the M from this symbol, or from this symbol. So M, there is K, so we can write 1 plus K is equals to K plus 1. So we can write this K, plus there is only one M, 1. So this is the step how we get this formula. Is it easy, right? Thank you for watching my video. I hope you enjoyed my video. Don't forget to like, comment, and subscribe. Enjoy!